Hello everyone. Today we'll talk about the solution to the problem final array state after k multiplication operations 1. This is yet another staircase problem, so if you've been solving dailies regularly up to now, then you should be very well aware of how to solve it. We can use binary search on the answer, we can use a heap. I'm of course going to be showing the heap solution because we can do it here. Now, this is classified as easy, but if you're trying to solve it in n log n, I'd say that it's more of a medium, both because you have to know the technique, binary search on the answer or a heap. Those are techniques, they are not trivial for beginner programmers. But also there is a trick here, or rather maybe just a bit of difficulty with indirection. Because we cannot just build a heap of all the values, we have to maintain the order of those values. We have to return the array nums after all the operations. And while it's not that difficult to do it, of course we have to maintain on our priority queue both the value and the index of that value, and we can modify the nums array in place. It's still a bit of added difficulty sprinkled on top. So the solution is just priority queue built on pairs of value index. We don't care about sorting by index. We only care about sorting, well, we care about sorting by index, but it just is sorted naturally. Select the one that appears first. So vi for iv in enumerate nums, very standard. Heapify the whole list. This is in linear time, that's why you use heapify, and we simulate all the k steps where we take the best value and its index, multiply that value by the multiplier, remember it in the original list, and push back the new value and the index to our priority queue. And at the end, of course, we return the final list. So the code is very short, but it both uses a data structure and has this added difficulty of indirection. So don't worry if you're a beginner and you had problems solving this in n log n. This is a medium problem, but it's a nice introduction to how to use a heap and to thinking about this indirection and maintaining order.